In this video, we'll try to explore LlamaIndex multi-modal capabilities, and using this capability, we'll try to interact with images and we'll try to get a structured output from the image. So here is a sample. This particular image, as you can see, is from Byte.Go, and they have explained how to improve API performance. In this one, there are certain features like pagination, async logging, caching, and all those things. In the second column, we do have a design flow. And in the third column, there are some description about the features, what they have mentioned over here. So now what we are going to use, we are going to use the LlamaIndex multi-modal capability. And under that, we will try to use GPT-4o model. And our end goal would be to get a response like this. In the title, we should be getting how to improve API performance. Then we can have another field like this property, what is there in this particular image, and then some kind of description, what this particular image is talking about. And then under the features, we would like to highlight pagination, async logging, caching, payload, and connection pool. And along with that, actually there would be some description. So this is what actually we are going to achieve in this video. And for that, we have to rely on certain packages. So if you already have LlamaIndex installed on your system, then you can just go ahead and upgrade it. So you have to upgrade your LlamaIndex package, and along with that you have to upgrade this particular package as well, which would help us to invoke multi-modal capabilities. So you can just go ahead and upgrade these packages. If you don't have it, then you can just go ahead and remove this -u. And then you can just run pip install LlamaIndex and pip install LlamaIndex multi-modal LLMs OpenAI. So with all these things in place, we can get started with our code. So let me go back to my Visual Studio, and actually we are going to start from here. So you can see the first thing what we need to do is invoke our model. And in this case, because we are looking for the multi-modal capabilities, so we are going to rely on this OpenAI multi-modal. And this OpenAI multi-modal is going to come from here. So under LlamaIndex, we do have multi-modal LLMs, and under that we do have OpenAI. So we have to import OpenAI multi-modal from there, and you can see like there are a lot of parameters that we can pass. So the default model which it supports is GPT-4 Vision Preview, but we would like to go ahead with GPT-4o. We can just go ahead and mention that model over here, whatever we want to utilize. And after that, another parameter what we are using is max new tokens. Again, you can see the default is going to be 300. You can go ahead and increase this number. And then there are other parameters also which you can utilize it based on your requirement. After that, I have just put that particular image in the data folder. So you can see like I do have some other files along with this image. So I just want to look for this particular PNG image. So I have just defined it under this extensions, and please do note like it's under a list. And then actually this required extension, we can just pass it to simple directory reader, which we were using earlier to load our documents. Here also actually we can use the same simple directory reader to load our images as well. We just have to point it to our folder. So we are just pointing it to data folder over here. And after that, you can see I'm just passing this particular extension so that it can only pick this .png image. Now, once this is done, we just have to follow the similar practice what we have been following earlier. So we have to just invoke this load data method, and then it will create a particular document. Now we have to see whether we are able to capture the image under this or not. So for that, actually you can just utilize this piece of code where actually we have to plot this particular image so that like we can see it. For this plotting, we are going to use this matplotlib.pyplot. If you want to utilize this, then again you have to install this particular package that you can install it using pip install matplotlib command. I'm just calling it as a PLT, and then I'm just using this PLT over here to draw the axis. So this would help you to see like whether your images has been loaded or not. So let me just go ahead and try to run this. It took around a minute, but after that I just got this pop-up. So it means like my image has been loaded as a document and it's able to capture it. So let me close it. So now actually we can just comment out this piece of code. Now let's go to another important section of the code, which is going to be this multi-modal completion program. This would be required to invoke those multi-modal capabilities, and under this only we are going to pass everything whatever we are going to declare in this code. So this multi-modal completion program is going to come from LlamaIndex.code or program. And under this multi-modal completion program, we have to define certain things. So first thing what we have to define under this is going to be our multi-modal LLM. We just have to make sure whatever model we are passing under it, it should be having the multi-modal capabilities. So we know like GPT-4o is having the multi-modal capabilities. We can also define any of the models. It could be Google's model or it could be another version of GPT-4 series, but it should be supporting those multi-modal capabilities. If you're trying to pass a model which doesn't have the multi-modal capabilities, for an example like GPT 3.5 Turbo, it doesn't support the multi-modal capabilities. So if you are trying to pass that particular multi-modal over here, you are not going to get the required output. This is the multi-modal LLM. Under that, you can see we have defined this LLM GPT-4o, and this we have invoked it over here. So we are just using this LLM GPT_4o, which we have invoked using this OpenAI multi-modal. So next thing what we have defined is prompt template string. So here we have just set use the given image about the improving the performance of API to extract data from it and store it into the provided data class. Now what is this particular data class? So this would help us to define the structure for our output. When we say okay, we are going to get a structured output from our image, then we have to let this model know what kind of structure we are talking about. So that particular structure we can define it using something called Pydantic classes. You can see this particular Pydantic is in LlamaIndex.co.bridge, and under that we are just invoking two things. One is the base model and one is the field. Now this class actually you can define it as per your wish. So I have just given this class name as a API features, but under that you have to make sure like you are passing this base model. Once you define your class, after that you have to define what exactly is this particular class is going to do. We have just defined okay, data class for storing text attribute of a performant API features. Now under this you have to define the structure in which actually you want that output to be generated. Now if you go back to our diagram, we could see like we have defined the title, property and the features, and feature is a kind of list what we want. So similarly actually we have to define things over here. You can see we have defined the title, and then what is that going to be type of this title, and under field I can provide the description what this particular title is going to hold. It will help the LLM model to identify what particular information it has to put it into this particular field. So please make sure like you define the description for each and every field which you are planning to get in the structured output. These three fields are going to be of same format. So we do have the string and string over here, and then the description. Features, as we have seen in the diagram, it should be of type list, and I can also update the description. Now we have defined this particular class. So what we can do, again, we can go to this multi-modal, and from default you can see like we do have an option of output class also. So this we can use it over here and pass our class. So this multi-modal now knows okay, which particular model are we using, what exactly it needs to do, and because we have mentioned okay, store the data into the provided data class, so which class we are talking about over here. Now once everything is done, we can just go ahead invoke this program method. So this program which we have invoked from here, we can just go ahead and just run it. I am just passing the image documents under it because we do have only one image as of now. Can just pass our image documents like this, what we have mentioned over here, and this 0th is talking about the first image in the image document. So let me just try to run this code now, and you can see we have got this output where you can see the title is how to improve API performance. Then we do have the property, then we do have the description, what we have mentioned over here, and then you can see for the features we are getting something like a list because this is what we have defined over here, and under that list we can see the pagination is first attribute, and then there is some description. And please do know that I have updated this description to include the description as well, like attributes of the image along with the description, and that's why I am getting this particular description with these particular features. Along with pagination we are getting a sync logging and other attributes as well of the images. Let me try to get another variant of output. As we can see in this particular image, as of now in the output we are getting all these columns, and then there is some description along with it. But what I want in this new variant, I need to have this particular feature, then some description about this particular diagram, and then something about the description what we are getting over here, right? So in this case what exactly we need to do, we cannot define our feature as a list of a string, because under that feature we are going to get all those attributes. Instead of defining this feature as a list of a string, we can define it as another class. So let me update this, and we can just call it feature description. And under that feature description, we can have name, description, and benefits. Under the name, we are going to ask for the name of the feature or name of the attribute. Then under the description, we are going to ask for summary of high level flow. And then in the benefits, we are going to get the benefit of the feature. And now because we have defined this particular class as a feature description, so instead of string, I can just define it as a features description. And then I have to update the description of this particular field as well. So I'm just going to call it list of features. Now let's try to run this code. So this is what actually we were looking for. So if I compare this particular output with the earlier one, earlier we were getting a title, which is okay, the property and the description, which is okay till here. But after that we were getting a features, and under that feature we were getting one field as attributes, and then there was some description around it. But now under that also we are getting a feature description. Feature description also actually we have just segregated it out into different fields. So we do have name, then we do have the description, and then we do have the benefits. So similarly, feature description for another attribute and all those things. So this is how you can control the output, what we are going to get from an image. So if you're looking for a structured output, then it totally depends on and how well you have designed your Pydantic class, and then you can get the desired output as needed. So that's all for this video. Thank you for watching.